Thank you for attending my talk, especially because this is the last session of the day. You could also go into the city, have some beers, but you're here with me, so thank you for that. Today we're going to talk about test-driven development and generative AI, and we're going to see if this is a perfect pairing. I would like to start with a little introduction why I'm here talking about this subject. So last year I gave a talk called The Battle of the AI Coding Assistants. I gave this talk at multiple conferences and multiple meetups, and in this talk I compared different AI coding assistants. One of the features that I showed off was the fact that AI assistants are capable of generating tests. So we give them our implementation and we ask the AI to come up with tests, and it works pretty well. At one of those conferences, at the end, a discussion started, and in this discussion somebody asked, but can we also do it the other way around? Can I provide unit tests to the AI and then the AI comes up with the implementation? And I said, that's an interesting idea. I don't know, but I'm going to investigate. And last year I started investigating, and that's led to this talk. So the second thing I would like to do is title this section, because there are 3 IT concepts in the title, and 2 of them are really obvious. The first one, of course, is test-driven development. Second one, also really obvious, generative AI. But the third one is a little bit hidden in the subtitle. And the third one is pair programming. So what we're going to do in the next 45 minutes, we're going to see if we can combine those 3 concepts into a new concept. But before I'm going to do that, I'm going to spend 1 or 2 minutes on talking about those 3 concepts so we're all on the same page. The first one, generative AI. Now, ChatGPT is the most famous one. It was introduced 18 months ago, only 18 months ago. It feels so much longer. Since that moment, all big IT companies created their own AI chatbots, and nowadays we have a lot. And the development is going really rapid. Last Monday, OpenAI came up with a new model. Yesterday, Google announced all kind of stuff, and today I'm talking here, so it's really going fast. All those AI chatbots out there are powered by a technique called large language model. And those models are pretty good at generating text and code. And code is the text that we're going to use in this presentation. So then we have test-driven development. You can have entire conference about this subject, but I'm going to boil it down to writing tests in advance. Why is this better than doing it the other way around? There are several reasons for that as well, but the thing I really like is the fact that imagine you're creating an implementation, it contains a bug you do not know about, then you write the tests. Those tests will not find that bug because we're all programmers and we all think we're flawless, right? So if you write an implementation, it's flawless. But then you go to your test and then the test will not find that bug. If you do it the other way around, you first write the test and then write the implementation, the chances of this happening is far smaller. Also, I'm a firm believer of the following. The more you think about something, the better the end result will be. So if you first write your tests, then you think a lot about your implementation, and therefore your implementation will be better. And it works really well with pair programming. So let's talk a little bit about pair programming. Pair programming is writing softwares in pairs. Now that's really simple. You sit together behind one computer and you're gonna write some software. Normally you have 2 roles. We have the driver, that's the one behind the keyboard, and that's the one writing the implementation. And the other one is called the observer or the navigator, and that's the one you discuss with, and that's the one who's giving live feedback while you're writing the implementation or test. Another thing that is a lot of people do while pair programming, the first person writes the test, then they switch chairs, and the second person writes the implementation. So, can we combine those 3 IT concepts in a perfect tripling? What we're going to do, we're going to do pair programming with the Gen AI. The human will write the test, and the AI will try to write the implementation. I call this test-driven generation, so not test-driven development, but test-driven generation, TDG. So, in this idea, in this concept, tests have a double purpose. And the first one is obvious, I already talked about it, that is unit tests are used as the input when we're talking to the large language model. But the second one is probably more important, and that's the fact that we're going to use the test to check for correctness. You've all been using AI chatbots for the last 18 months, and as we all know, AIs can be tricky because they sometimes make things up. And that's a problem, especially when we want to write implementations. So let me give you a little story in which it became pretty problematic that an AI came up with made-up facts. So a few weeks ago, there was a story in the news about Air Canada. Air Canada is an airliner, and they have a website. On their website, they had a chatbot, and they decided to make their chatbot better. And they decided to use a large language model, so the chatbot would give more natural answers. A customer was chatting with this chatbot, and as you already can guess, the chatbot started to make things up. They were chatting about refund policies. The customer made screenshots, and a few weeks later, he decided to ask for a refund. So he called the help desk with real humans behind it, and the human said, no, this is not true. The chatbot made a mistake. The customer went to court, and the judge agreed with the customer. The judge said, I don't care if it's a chatbot on your website or an AI or a human. If it's on your website, it is true. Therefore, you have to refund the ticket. Next day, the chatbot was offline. Yeah, so this story illustrates that we have to check the output of large language models. Luckily, when we're talking about code, we have a way of doing that. We have our unit test. So we use our unit test to check if the implementation created by an AI is a correct implementation. So my name is Bouke Nijhuis. I'm the CTO at a company called Think ICT, and again, we're going to talk about test-driven development and Gen AI, its intersection, and we're going to see if this is a perfect pairing. So I created a little schema to show off the concept in a nutshell. I'm first going to walk through the schema from the left to the right, and this is the happy flow, and then I'm going to talk about the loops in there. So on the left, we have tests. Those are input. We feed them to the Gen AI. We ask the Gen AI to come up with an implementation that passes those tests. And we're talking happy flow, so we get a perfect implementation. That's the implementation, that's the box in the middle. Again, we're talking happy flow, so all tests pass. So we follow the yes arrow, and we're at the done circle. And now we have a perfect production-ready implementation that we can deploy. Of course, we all know that theory and practice are always different. So if you do this in real life, things go wrong, and that's where the loops come in. So let's first talk about the small loop underneath Gen AI. Sometimes Gen AI comes up with an explanation instead of an implementation. You cannot run tests against explanations. Sometimes Gen AI comes up with non-compiling code. Again, you cannot run tests against non-compiling code. So therefore, we sometimes have to ask for another implementation. Now we're going to talk about the big loop, the one on top. So in practice, not all tests pass the first time. If that happens, we extract the errors from the tests, we feed them back to the Gen AI, and we ask the Gen AI to come up with a solution that solves the extracted errors. And this is the idea of this talk in a nutshell. And the best way to show you, of course, is by doing a demo. So we're going to start really, really simple. We're going to do an odd-even test. Now let me show you what it is. I created a little test called the odd-even test. And as you can see, it is really, really simple. We expect an object with the name odd-even. It has one method called isEven. If you provide an even number, it should return true. If you provide an odd number, it should return false, right? Pretty simple, but this is just to show off how the process works. So I'm going to select everything, I'm going to copy it, I'm going to go to ChatGPT, and I'm going to ask it to come up with an implementation. So I'm going to paste the test from my IDE. I'm going to press enter. That worked last week, but now we have a new interface. So apparently I have to do Command Enter. And we wait till we get a solution, and this looks pretty fine, right? So I'm gonna copy the code. Funny, it's all in Dutch. And I'm gonna go here, I'm gonna go to the test subject. Notice that there is a dummy implementation who always returns false. I'm gonna select everything, paste the solution from ChatGPT, go back to the tests, run the test, hold my fingers crossed, and hope for a green check mark. And there it is, green check mark. Okay, this was a really simple example. Let's do something more difficult, a little bit more difficult, which is prime number generation. So again, I have a test called prime number generator test. Let me make some space. So one test is called under 50. We expect an object called prime number generator. It has one method called generate, which takes an integer input. This number denotes the upper bound of prime numbers to generate. And if the input is 50, we expect this list of prime numbers to be returned. So again, I'm going to copy this. I'm going to go to ChatGPT, ask for a new one, a new context, and prompt it again. I paste the test, press enter, command enter. We go down, and now the solution will be more difficult, but we're not going to focus too much on that, because we have tests for that, of course. So I'm going to copy the code, go back to my IDE, to my test subject. Notice this is a dummy implementation. I'm going to select all, going to paste it, back to the test, run the test. And again, green check mark. So the principle works. Thank you for attending my talk. You can go. Oh, you don't believe me? Okay, cool. So the principle works. I'm really happy with that, but there are big two problems with this approach. And let's first discuss the first problem, and that's the fact that I think there are too many manual steps. So the idea works, but if you have to do all those steps, now let me take you through it again. I was in my IDE, I copied code, I went to my browser, I had to type a prompt, I had to paste the code from my IDE, I had to wait for the answer, I had to extract the code, go back to my IDE, go to the test subject, paste it, run the test. Talking about this makes me already tired. So we have to do better. Let's automate this. Can I do something cool for the photo? Smile. Okay, sorry. Where was I? Let's automate this. So sounds pretty simple, right? There weren't too many tasks I just did. I just did it in under a minute in my IDE and my browser. Yeah, famous last words. Like a real project, it was harder than expected. So I expected to work 3 to 5 evenings on it, but in the end, it was 10 to 15 evenings and a few weekends. But in the end, I had something. It turns out that the IDE does a lot of work for you. And of course, I already knew that the IDE does a lot of work for me, because otherwise I wouldn't use the IDE, right? But it never became more apparent than in this project what it all did for me. So in the end, I had a tool called the test-driven generator. And this is, of course, the point in the presentation. Oh no, I want to demo it to you. But first, I'm going to explain all the steps that the tool does. So you probably recognize this from a schema I've shown you before. This is a small part of it. And the first thing we have to do, we have to call an API of a generative AI. So when I started this project, I started out by using ChatGPT. This is not difficult, but it is work. You have to have your secret key, you have to call the API, you have to check the answer, stuff like that. Secondly, you have to interpret the reply. So you saw me in the browser going to ChatGPT, click on the copy code, so I extracted the code from the answer. This is a little bit more difficult if you want to do this in code, because I told you before, sometimes the AI comes up with an explanation. It's pretty difficult to extract the code then. Sometimes it comes up with explanations and implementations, then you have to separate those. So again, not a lot of work, but it is a little bit more difficult than I expected. Then you have to create a file. This file has to have the right file name. As you all know, the file name should be equal to the public class name. So I need a feature to extract the public class name from the code. Secondly, if there are packages involved, I have to create a package structure in the file system to get the file in the right directory. Again, I need a feature to extract the package name from the code. Then we go to the next part of the schema. I have to compile both files. I didn't think of that when I started, in my head, I was thinking, I'm going to create this tool. You have to compile both files. This is something that the IDE does for you. You never think about it, it just works. Then you have to load those compiled files into the JVM. Again, you don't think about that. IDE does all the work for you. Then you have to add a test library. If you don't have a test library, you cannot run tests. Also something that is taken care of by other systems than myself. Then I have to run the tests from code. I don't know, raise of hands who has ever run tests from code? 1, 2, 3. Okay, a few people. I never done that. It's possible, it's not that difficult, but again, it is work. Also, this is pretty simple from your IDE, right? You press on the little green triangle and it just works. Next, you have to interpret the results from the tests. Again, pretty simple in your IDE. And you look at all the yellow crosses and you see what goes wrong. Now you have to extract it from data structures. And in the end, if I do put all the files in the temp directory and if all tests pass, so we have a perfect production-ready implementation, I copy this implementation back to the project where the unit test file was so we can directly use it. Then we have to talk about the big loop. First thing you have to do, you have to extract the errors from the test that did not pass. Then you have to continue the conversation. So you pass the errors back to the generative AI and you ask the Gen AI to come up with a better solution. You just saw me in the browser when I was talking to ChatGPT, and you all have done that before. When you talk to ChatGPT in a browser, it keeps context. It remembers what you talked about before, right? You can refer back to things that happened earlier. This is not the case when you're using the ChatGPT API. You have to build the context mechanism yourself. And lastly, I needed proper logging. As all good projects, I started out with a few system out print lines. And that was enough until you do a few loops through the schema I've shown you before. So not all tests pass, you get a new implementation, another test passes, but not all of them, another loop. And all those loops contain a lot of lines of code. You have the prompt contains the tests, then you get the answer from the large language model, then you have to extract errors, and you do this a few times, and we're talking about hundreds and hundreds of lines of text. So proper logging was needed. I told you a few minutes ago that I started out by using ChatGPT, but halfway the project I decided, maybe it's time to check out local large language models, because I heard a lot about them and more people are talking about them, and they turned out to be easier and faster than I expected. My expectation was I have to download a big file, do 20 manual steps, and then fingers crossed, let's hope that it works. Turns out you only have to download one tool, Olama. You run the tool and you have a local large language model running. Also, I expected those tools to be slow, so I expected to get an answer in minutes, but it turned out you get a proper answer in tens of seconds. There are lots of local coding large language models out there. I tried about 10, and in the end, I settled on something called Llama 3. It came out a few weeks ago, and it turned out to be the best one for my use case. Also notice that I'm saying coding large language model. There are even more general purpose large language models out there. We're talking about hundreds. So there's a lot to choose from. Finally, I give a demo. So this is for me. I always forget to do this when I practice for the talk. So sorry for that. So now I remove all the things I just did. I remove all the implementations we just created with JetGPT. And let me prove that to you. You see, dummy implementation. Dummy implementation. Wrong button. Okay, we're directly going to go to prime number generation this time. So let's go over here. Let's do the prime number generate test, this one. So how does the tool work? The tool is a simple jar file. So you see there's a jar file. I can just use this jar file and it expects at least one input, and that's the path to the test file that you want to use as input. So what I'm going to do, I'm going to copy the path to the file on top. I'm going to put it over here and I'm going to press enter. Now, as you can see, there is some logging. We're in the first test loop. The test loop is the big loop, the loop on top. And we're also in the first code loop. That's the small loop underneath the Gen AI in the schema. So now we're asking Llama 3 on my machine, can you find a solution? Now, as you can see, it found one test, and all tests succeeded. That means we have production-ready code. Here you can see it put the solution somewhere in the project. Let's see what it came up with. Now, as you can see, the dummy implementation is gone, and it put real code in there. I don't really care about the code because I have tests, and if all my tests pass, we're done, right? We have code that we can deploy. So the tool works too, and that's really nice because now I have a tool which can generate code for me. I don't have to do all the manual steps anywhere. I can just start the tool, get a cup of coffee, come back, and hopefully get an implementation that I can use. So how would you add features in this concept? So in the past, we would go to our implementation and we would add more algorithms, right, to make our product more feature complete. But we do not touch the implementation in this concept. So what we do, we just write more tests. If you want more features, you write more tests. What we're actually doing, we're adding specifications, because we all know tests are a form of specifications. So let's give a little demo about that as well. So we go back to the prime number test. Let me get some space. So what we're going to do, we're going to add a test. Oh yeah, let me first explain what I want to test. So you've seen we do not know about negative prime numbers. So in the code, I had a generate method and I gave it 50. But if you give it a negative number, you're asking for negative prime numbers, which is impossible. Therefore, we're going to create a test that says if you're asking for negative prime numbers, the implementation should throw an exception. That's what we're going to do. So negative upper bounds are not allowed. So I'm going to write a test. And do you notice this? I like this a lot. This is the new IntelliJ one-line completion. So I have a test called under 50, so probably I want something that's called over 50. It's not correct, but I like it anyway. So let's do this. Negative input. And hey, again, the one-line completion. I need this thing, so this is really good. So I'm going to select it, accept it. What we're going to do, this is incorrect again. We're going to check if we're going to assert if an exception is thrown. So we're going to use something called assert throws. This one. The first thing I have to do, I have to explain which exception I'm expecting, and that's a runtime exception. Hey, look at that. This line is perfect. I'm going to accept it. So first, you give the class that you expect to be thrown, and then you need a lambda that should throw the exception. And this is exactly what I wanted to test. So thank you, IntelliJ, for helping me out here so well. So let's run the code, and I expect one green test and one yellow test. And as you can see, we have one green test and one yellow test. And that's logical, because we didn't ask for this new feature yet. So I go here, I run the same command again, but notice that the file now contains two test classes. And what I expect is that it comes up with a solution. Oh, it's pretty fast, right? For a local large language model. So two tests are found and two succeeded. Now let's see if we can find a difference in the solution. And this is exactly what I was asking for. So yeah, I would say nice demo. Add features by adding tests. This is the idea behind this concept. So what about existing code? I assume most people in the room here are developers. Who thinks him or herself a developer? A lot of hands. Who fell asleep? Few more hands. Okay, cool. So I assume everybody wrote at least 100 or maybe thousands of unit tests in his life. So what I did, I used the tool and I provided existing tests. So tests that I wrote in the past, but I also wrote the implementation. And then you can see what happens. And actually, I used the tool to improve the tool. Let me explain to you. So in this tool, there's a class called code container. And the code container has several features. One of its features, of course, is holding the code. So the LLM comes up with output, we extract the code, and we put it in this class. Then another feature is that there should be a method that's capable of extracting the public class name, so we can create the proper file name. So we can put the file, put the code in the right file. Another feature it has is we should be able to extract the package name, so we can put the file in the right directory. That's what the code container does. And as we all know, if you have programmed for a few years, the best way to solve those two features, so extracting the file name and extracting the package name, is by using regular expressions. I have a small confession to make. I am really bad at writing regular expressions. So I wrote a really crappy string manipulation solution. It worked until I started adding test cases. Things start to break. So I needed a better implementation. But luckily now I have a tool that can create implementations for me when I have the unit tests. So let's have a look at this file. Code container test. Let me make some space. Wrong button. Let me make some space. And so the first one is file name extraction. So what you see are a few classes over here. Let me do that properly, like this. And I put random spaces in different spots. That really breaks your string manipulation solution. I notice that I have classes, I have public classes. Then over here we have the expected file names. And then over here we have messages. Why do I have messages? Now, I think it's a good way to document your test, but in this case, it also really helps the large language model if you tell it exactly what went wrong. So it's easier for the large language model to come up with a better solution. Okay, then we have to extract the package name. Again, here I have some example code. And notice that again, random spaces. Notice that I have single level packages, multiple level packages. And notice that I have code without package, because package, of course, is an optional thing. We don't have to use it in Java. Again, the answers and messages. Okay, now we have this. I'm going to copy the path to the file. I'm going to go over here, delete the last file like this, paste in the new file. Notice that it says code container test at the end. And again, we're going to ask my local LLM to come up with a solution for this problem. This is already a lot harder than the previous demos that I did. And normally when I practice for this talk, 50% of the times it's capable of solving this issue. As you can see, something happened. 2 tests are found, but none succeeded. So the local LLM came up with a solution, but 0 of the tests passed. So the solution is not good enough. Let's have a look at what's happening under the water. So I have a log file called generator log. Here you can see it's the Olama family. I'm using llama tree. Here you see the prompt, at least part of the prompt. In the prompt is the test. So you've seen this before as well. And let's see if we can find which test failed. So over here it says package name extraction should be able to handle spaces between the package keyword and the package name. So I expect the output to be cats, but it was empty. Now, too bad. As you can see, it's still running. There are 2 things you can do whenever there is no solution found. Now, the first one is retry. This sounds insane, but it's really true. We all know about the large language models. They sometimes get stuck in a certain corner. We call this hallucinations. So sometimes it really helps to deal with it again. But if that also doesn't work, we're just going to upgrade the large language model. I told you I'm really happy with my local LLM because it's easier and faster than I expected. But they do not compare to the ones in the cloud. The ones in the cloud are so much better. Unfortunately, they're also more expensive. So, hey, something fun happened. Notice what happened? So, 0 succeeded test, 1 succeeded test. So, feeding back the errors, feeding back the tests that do not pass, helps the AI to come up with a better solution. And it would be really cool if it would find a solution, but I think it will not. So I'm going to prepare something while it's still running. I'm going to prepare another run. Not this, not this, not this. Ah, too bad. My command is not here. It was a pretty long command, so I'm not going to work. Too bad. Doesn't matter. So no solution found. What I'm going to do, let me show you. What I'm going to do is I'm going to talk to ChatGPT-4 in the cloud. If you do that, we have to add some flags. So over here I'm going to say test file. And over here I'm going to say family ChatGPT. If you do this, it defaults to GPT-4. It's not even the best one out there. Up till last Monday, I think GPT-4 Turbo was the best one, and I think now GPT-4o is the best one, but I didn't really pay close attention to what happened on Monday evening. As you can see, it came up with a solution. It was not a perfect solution because only one of the two tests succeeded. So now it tries to come up with a better solution. We can take a look at the generator log again, this one, to show you that I'm really using JetGPT-4. You can see over here, the family is JetGPT and the model is GPT-4. It takes a long time for the second attempt. Apparently it's busy in the cloud. But in the end, look at that. 2 tests found and 2 tests succeeded. So let's have a look at what it created. I need some more space. So what we can see, interesting, it is a replace all. I've never seen this solution before. And this is the charm of using an AI assistant. It always surprises you. But apparently it works because the test succeeded, right? And this one contains content. Yeah, also a replace all. Wow. Okay. So that's what I meant. Just use your existing test, run them, let's see what happens. Maybe something interesting happens. Maybe this is better. Actually, I know this is better than I created. My poor string manipulation solution, I'm pretty sure this is better. Okay, so I told you there are 2 problems with this approach. And the first one was too many manual steps. We solved it with a tool. But the second problem is, how do we handle libraries and frameworks? All the examples that I gave you are plain Java code, which is cool, but that's not something we do at our job, at our daily job, right? I think everybody in this room is using libraries and frameworks. Therefore, how do we solve that? The current implementation of the tool, the jar file that takes a test file as input, I think it's pretty impossible to extract from a test file which libraries and frameworks you are using. So I think that is an unsolvable problem. So I started thinking, how do I solve this? Who knows about libraries and frameworks? Who knows about dependencies? And if you look at it that way, it's pretty simple. The build system knows all about your dependencies. It knows all about your libraries. It knows all about your frameworks. So I decided to create a Maven plugin. I prefer Maven over Gradle because I just have more experience with Maven. I just went to 2 talks, and in every talk they were asking how many people are using Maven and how many people are using Gradle. Maven every time won, so apparently I'm in the winning camp. But this should also work for Gradle. So I just told you that. So I never wrote a Maven plugin before. How many people wrote a Maven plugin? Oh, okay, I would say 10%. That's more than I expected. I never did it before, so I started looking up how it works. And I expected a Maven plugin to load all dependencies for me. So to prime your JVM and you could just do your thing, right? That's the idea. Turns out not to be the case. So if you have a Maven plugin, you still have to load all the dependencies yourself. But luckily, this is pretty easy because as a Maven plugin, you have easy access to the list of dependencies. So you write your own custom class loader. Who wrote a custom class loader? Okay, I would say 5%. It's not really hard. You look up a few examples. But yeah, if you have never done it before, it takes a little bit of time. Then I came to the next problem. In this tool, sometimes it comes up with an implementation, but not all tests pass. Then you have to do another run, right? And then it comes up with a new implementation. So if you have a new implementation, what you would like to do is you would like to reload the implementation. So you would like to drop the old class and inject a new class. This is not something that class loaders support. So my solution was brute force, just throw away the old class loader and create a new one. Feels really wasteful, but it does work. So, demo time again. What time are we? Okay. I created a really simple test called the endpoint test. So what we're going to do, let me show you, endpoint test. I created a simple Spring Boot test, and I'm going to assume you're all familiar with this, and otherwise you probably will pick it up. It's not that difficult. It's good practice to have a random port. So that's the thing you find over here. Then we have the test REST template, so we can do a REST call. What we're going to do a get on the root of localhost, and then the random port. And we expect this endpoint. Whoa, wrong button. Wow, this was not. Okay, now you can see it's real. Things go wrong. I didn't plan this. This shouldn't happen. Sorry for that. I just misclicked. I expect the endpoint to return hello world. Now, I told you now we have a Maven plugin, so it works a little bit different than only using a jar file. So let's go to the POM file. We have a new plugin called the Test-Driven Generation Maven plugin. Best name ever, right? Then the most important part is its configuration, and its most important input is, of course, the path to the JUnit 5 test file. And as you can see, it's already pointing to the right test file. So now we go again over here, and I'm going to say Maven test-driven generation generate. Okay, so as you do this, let me make this a little bit bigger. By now you should recognize those command lines. So the Maven plugin is using the jar file to come up with a solution. Oh, wow, it's pretty fast. So as you can see, one test found, one succeeded. So let's have a look at the test that it found. Where am I? I'm over here, and then I need this. So it created a new Spring Boot, go away, Spring Boot application with a REST controller, a get mapping on root, and it returns hello world. Hey, not difficult, but hey, this shows off the fact that the tool can also handle frameworks and libraries. Let's do a little bit more advanced example, which is called the endpoint age test. So this one. So again, it's all the same. The difference is over here. So what we're going to do, we're going to provide the endpoint with a birth date, and then we expect it to return the age. And this is not a trivial problem. But let me first walk you through the test cases. So if you're born on the 1st of January in 2024, you're 0. 1st of January in 2020, you're 4. I just said 4, right? So this one should be 0. If you're born the 1st of January of 2000, you're 24. But if you're born the last day of 2000, you still have to become 24. You're 23. And this is where part of the difficulties lie with age calculation. We expect there to be an age endpoint, and we expect the last part of the URL to be a birthday in this format. Not sure how this format is called, but that's the one. So again, I'm going to copy the path to the file. Now I go to my POM, and I don't really need the path. I'm just going to say age over here. I'm going to go over here, and I'm going to run the Maven command again. So I'm still working, since I switched over to the Maven model, I started working again with my local model. So this is running against Llama 3. So the previous demo was done with a local LLM Llama 3. Normally, it is not capable of solving this. We're going to give it one more try. We're going to give it one try, so we'll wait till it's finished. But in most cases, I would say 10% of the cases, it is capable of solving a problem of this magnitude. So I'm going to prepare my POM file. Because I told you before, what do you do whenever it doesn't work? You upgrade your large language model. So over here, if I remove this, with the next run, it will use GPT-4. Notice that there are more stuff you can do. You can also specify timeout. You can specify a server. You see, this is the one I use for local testing. And you can also play with the prompts. We're not going to wait on this because I'm pretty sure it will not succeed. And maybe if it succeeds, we can always watch it later. So I'm again going to do a Maven test-driven generation generate. And notice that I now have uncommented those two lines. So now it's using GPT-4 in the cloud. Normally GPT-4 in the cloud can solve this. Sometimes it only needs one shot, and sometimes it needs 2 or 3 shots. And one time when I was practicing, it didn't work. So let's hope that will not happen in this presentation. Build success. So one-shot solution. Let's have a look at the solution. So over here, let me reload. I have a new application. And again, we have a Spring Boot application. There is a REST controller. There's a get mapping on the desired endpoint, age, and then a birth date. Notice that we have a pet variable. And this is interesting. The solution works for the test cases, but it's not the solution that we really want. For people who can read pretty fast, current date, this is not the current date. But it works for the test cases that I gave it. So this is my mistake. This is a human mistake. I should have put more edge cases into the test, but I wanted to keep the test simple for the demo so you people can easily follow along. But again, a surprising result from our friend, the AI. Okay, cool. 4 minutes left. That's not a lot, right? The Maven plugin works too. Yoo-hoo! Now we can also use it at our daily job because everybody's using frameworks and libraries. So what does work well? Give it contained problems, not too many dependencies to the outside world. And so if there are well-defined binaries, I've just shown you prime number generation, I've shown you adding an exception, I've shown you a simple endpoint, I've shown you the age endpoint. Those things work well. I think it can do problems that you would give to a junior developer. What if it doesn't work? Now, first thing you do, you check the logs. During the demos, we did that once to see what happened. But in most cases, you have to upgrade the large language model. What if that doesn't work? You take the biggest, baddest, boldest large language model out there and it doesn't solve your problem. At least you have your unit test, right? So, in the worst, let me explain this. So, before this tool, I create my unit test, I create my implementation. Nowadays, I create my unit test, run the tool, get a coffee. If I'm lucky, I have an implementation. If I'm unlucky, hey, I got a coffee. And I still have the right implementation. So I didn't lose a lot, right? So nothing to lose. So pricing. Pretty non-existent when using your local large language model. My laptop heats up a little bit. My battery dies a little bit sooner. But probably you will not notice it on your bill. Small price when playing around with online AIs. I created this tool, Praxis for this talk. This is the second time I'm giving it. And it took me less than $10. I still have $3 left in my account from my first $10 at the API from ChatGPT. So I think still doable. Yeah, and it will become pricey when you use them a lot. But hey, there's a lot of progress in this area. The LLMs become better, cheaper, faster. So I think in the near future we will have a point that also the pricey thingy will go. It's become a commodity. So let's see what happens in the future. Can I use this myself? Yes, you can. I will share links afterwards. In the bottom right corner, you see my X handle or Twitter handle, as we call it in the past. Warning: this is POC level, proof of concept level. Of course, I wanted to create a production-ready tool that solved all problems in the world. Didn't happen. So it took far more time than I expected. So it works. I've shown the demos. This is the tool. But expect problems. You are warned. So actually I have 1 minute left, so I'm gonna skip a few. I have all kind of ideas for the future, but I'm just gonna do the last two ones. My end goal for this thingy is an IDE plugin. Picture this. You're in your IDE, you're writing your test, you right click, you click on generate implementation, you get your coffee, you come back, done. This is my end goal. But I specifically said my end goal because actually this is an other end goal, but it's not for me. Actually, I hope it will become part of Copilot or AI assistant. So if there are people from Microsoft, GitHub, JetBrains in the audience, please take it to your departments and make this happen. It would make me very, very happy. So, conclusion. TDD and Gen AI is a perfect pairing. The principle works. I've shown you multiple demos in which I showed off the principle, and I think it worked really well, even while doing live demos, which is always a little bit more harder than practicing at home. And the most important thing I can teach you is that we have to check the output of large language models. We do that in this case with by running unit tests against the output of the large language model. But I think everybody would benefit from checking this. Remember the Air Canada story. All large language models should be checked for correctness, at least all output. I'm not going to talk about this. Thank you. If you have any questions, please come down here. I know there's a thing with the app, but hey, time's up. Please come down here. I prefer one-on-one. Yeah, time is up. I have to. Yeah.
If you like, you can do
No, I prefer people to come down. Feedback is also more than welcome. So you can also come down to give feedback. You can talk to me in the hall. I hope everybody learned something new. I hope you enjoyed yourselves and enjoy the remainder of the conference. Bye-bye.